Bismillahirrahmanirrahim. Assalamualaikum. Selamat datang ke webinar Leaders in Innovation Fellowship Malaysia pagi ini. Forum ini dibuka kepada penaja program di United Kingdom. Jadi izinkan saya mengendalikan forum ini dalam bahasa Inggeris. Good morning and a very warm welcome, ladies and gentlemen, our audience that are on YouTube live streaming to Prototyping and Production Strategies for Innovation webinar series. The Leaders in Innovation Fellowships, we call LIFT for short, is part of the UK Newton Fund by the Royal Academy of Engineering in partnership with MIGHT Malaysia as the country partner. I am Fazlida from Universiti Teknologi Mara, UiTM, and I speak on behalf of the project team comprising of staff from UiTM, UM, IIUM, UTHM and UTM. The team are alumni of the LIFT Fellowship Program under the Royal Academy of Engineering UK, and this webinar is in collaboration with TPM, ITMA, MTDC, NTIS, MIGHT, CREST, and FMM. We have conducted 3 forum sessions under this scope, and this is our 4th forum with the title Industry Academia Partnership in Driving Innovation through Prototype Development and Production Strategies. What we hope from these forums are really to create more conversations on the chosen topic. We hope that more conversations lead to better communication and eventually assist all of us in making better informed decisions. We cannot expect to achieve strong partnerships or make wise and strategic decisions if there were to be a huge wall between different stages or different parties. And that's the point of this forum session, to tackle the issue of industry and academia partnerships. So today, I am absolutely pleased to introduce our 3 panelists, 3 strong figures representing highly important organizations in the Malaysian framework from both sides, the industry and the academia. Our first panelist is none other than Dr. NorAzmi Alias, Senior Vice President, Research and Talent Management, Collaborative Research in Engineering, Science and Technology, CREST Center. CREST is an industry-led collaborative platform. They are into industry-led E&E focused, market-driven R&D and research and development, talent development, commercialization. They are driven towards generating solutions with economic impact and forging local and international strategic partnerships with government, industry, academia collaboration. So Dr. NorAzmi, welcome. It's wonderful to have you on board. Our second panelist is a lady with vast experience, Dr. Helena Yeut. She's the Managing Director of Accel Graphic Systems in Berhad, and Dr. Helena is the Federation of Malaysian Manufacturers FMM Council member. She is also the Chairman of FMM Branding and Intellectual Property Committee. FMM is Malaysia's largest private sector economic organization, representing several companies of varying sizes. So welcome, Dr. Helena. It's a great pleasure to have you on board. And our third panelist, a strong force in setting up of Innovation and Technology Managers Association, ITMA in Malaysia, Professor Dr. Samsilah Roslan. Professor Samsilah is currently the president of ITMA, and ITMA serves as a platform for innovation and commercialization center for universities in Malaysia. And we all have heard of the outstanding hybrid model of Science Park and Tech Transfer Office, Putra Science Park, UPM. Professor Samsilah was the director of Putra Science Park in 2013 to 2019. Welcome, Prof. Samsilah. It's an honor to have you with us. Right, so now I will set the scene. So I'm citing this picture I found from the Royal Academy of Engineering UK website. It's a cover illustration of a document from the National Engineering Policy Centre. It's titled Late Stage R&D Business Perspectives. So I used this picture as well for the scene setting forum too, but I'll use it again because it shows an innovator with a benchtop physical mock-up and breadboards having to go through product development strategies before it is ready to be deployed or used by the society. And this journey includes integrating modules, field testing, getting regulatory and certification fulfilled, getting feedback and redesigning. And this long journey requires structured support, funding, and partners. And that's the scene. This question of partners and the kind of partnerships required to go through the journey. And I will leave it hanging at that because I'm not a very good storyteller, but that is the scene. So this forum will be conducted based on question and answers. I have a total of 9 predetermined questions for the honorable panelists to get the conversation going. And this will take in total about slightly more than an hour, after which we will take questions from the audience. So my respectable friend, Professor Dr. Shaliza Ibrahim of Universiti Malaya, who were also part of the LIFT Fellowship, like me, will be moderating the YouTube live chat and taking in questions from the audience. So now there are no presentations from the panelists, just questions and answer. And our first question goes to Dr. NorAzmi. Dr. NorAzmi, with your experience in fostering industry academia collaborations at different levels, I remember you coming to the university and all. So maybe you can share with us the current collaborative practices. What are available options in the national framework for industry academia partnerships? Over to you, Dr. NorAzmi.
Thank you, Dr. Wan, Fazlida. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning to all. My panelists, colleague in the space of innovation and research and development, right? So maybe I should start in terms of looking at the whole equation from ideation to conceptualization, prototyping, and the second round of prototyping in the closer to market, we call it MVP, and then the pre-com activity. Each of these, we simplify with very small block, one TRL 1 to all to 9. But actually, each of the steps take quite a long gestation period, right? It's basically require a very thoughtful exercise, right? Very careful planning, be very clear, and in mind what to be achieved, right? And when we started, when I came back in Malaysia in 1995, because I was from academia research, I worked for multinational company Motorola. When I came back and I said I need to continue to work with the academia to help me to get some of my things done that I could not afford, or don't have the facility or the resources to do so, right? So industry always looking at the academia to become the technology advisor or expert or or partners for them to solve problems that they don't have the resources or the ability to solve them, or they don't have the time to solve them, right? And therefore, this is one mode of what you call the outsourcing of the problem, if you may, to the academia. And I think that's the first mode of the collaboration. And I've been doing that ever since. Even when I was studying, we have this engineers from Texas Instruments back in Massachusetts came to our college, said, can you have to tell me what happened to my interface between my alumina and my epoxy, right? And so, this is, I think, the most, efficient way where the industry comes and seek for the help, right? Seek for the help from the academia. And nowadays you see a lot more of the, this one-to-one collaboration where, they really understand what they want to solve. They're looking in terms of, who do I talk to, who are the expert in academia that, industry can go and liaise with and, and seek for their, support to solve the problem, right? So in this case, I call it one-to-one collaboration. Some people call it co-development. There are many different terminology. And people like Eggert and Cooper, Cooper and Eggert from the product management institution. They call it concurrent engineering, where the technology is done by one group, and then the translating the technology to product development to the final product in the market is done by the product development team, right? It could be done within an organization or across different organization. In this case, we're talking about the entity who's want to develop a product with a certain problem to be solved, coming from the industry company, and then the entity that has the technology or the expertise to address a particular problem, to make the product better or to introduce new feature into the product will come from academia. So therefore, this is the most common way and the fastest way to get things started, because there's only two entities, right? You get the industry and you get the academia, and nothing else in between. So it's a direct contract, where industry will tell us, I have this problem, and I will quote one case where when you first started with Motorola, with this CREST program, we call for industry and say, do you have problems that you want to be solved but don't have the time or don't have the resources to do so? Can you, give these challenges to the academia, and so that they can propose how they can, help solve the problem. So one of the projects I want to quote here is from, Motorola. They have this two-way radio, just like your phone, has this, microphone. And the problem that they have is they have this wind noise that coming from the hissing sound, and they seek for somebody to actually address, what are the right features or what are the right design for them to apply. And the research is basically not even around electronics, not even around the area of so-called, communication, right? It's all around how do you study the effect of the wind blowing, through a different geometry, right? Because you create different kind of turbulence, and so that was the research done by this, Prof. Zaidi, in the USM. They have the lab called the Vibration Lab now, and it's basically just to understand and characterize the behavior of the so-called, wind in a different speed, different velocity, and does it create, turbulence, or does it create, sound, right? And from that research, and what happened is, because the Motorola engineer has the ability to take all this input from the research and convert into, now let's build a prototype. So you have this concurrent engineering between the academia, that doing the fundamental work, and then the translation of the fundamental into, features is done by the engineering team from Motorola, right? And we see a lot more of that, as we progress. We see, like, for example, another team in USM, Prof. Zaid, that's doing a lot more of image analysis, image analysis, and also in using optic to create, defect images in silicon, and help this company called TT Vision to create a new product to do a kind of online inspection system for wafer crack detection. So that's the first example. Is basically it's just a two-way kind of a partnership in terms of industry said, I have this problem, and can you help me to solve the problem? And therefore you go into this co-development mode, right? So I will not even talk about IP anything around here, just talking about the nature of the collaboration, right? The other part, I call it technology licensing, where the initial technology being developed, by the academia, because, I mean, we all read the same papers, we all read the same document, the same report, and the academia, technically understand what is the new trend in the market. And like I quote example, like for example, in biosensor, right? Biosensor, biosensing. Take one example that worked with the UiTM. I think Prof. Wan was working on that project, with a collaborator on developing biosensor for BRCA1, right? Detection, right? So I think the goal was very high goal, to build a sensor and also to able to detect the earliest possible of the BRCA1 gene, right? I think that the project comes to a point that they managed to develop the sensor and also the electronics and able to do detection. Of course, we don't expect that project to complete until a final product to be clinically trial. So the technology has been developed, with one particular company, and it's become an IP that's been created, right? So now a technology being created. So in order to move that technology to the next stage, this is where entity like CREST and MIGHT and few other entities, even like Nano Malaysia and whatnot, has the ability to link the researcher with the IP that has a large potential to link that to particular and industry partner that are gonna be co-developing and further develop that into product, right? And this is where we see that in terms of the biosensing work be done by Dr. Zaini Hareti, able to kind of change the bioreceptor at the tip of the sensor to go into now COVID-19 detection, right? And that's only one of the kind of tipping of the iceberg. There's a lot more other disease and other viruses that can be detected if she can actually tweak the so-called the bio receptor to detect certain disease and this certain virus. And I think these are a good example of where technology initially developed with one party, could be just internally developed within the research, do not involve any industry. As you develop this core IP, I call them, you build this core IP, and this is where the the industry partner or industry related kind of a organization able to say, okay, you have this, let me go and seek for your potential partners for the next stage, because you're already taking to tier 3 and 4. Now how do you move that to 6, 7 and beyond, right? And that will be the so-called the second nature. The third, hopefully I'm still within time, another one.
Okay.
The third, what I call a multi-stakeholders collaboration model. Yeah, because you don't have one-to-one, you don't have basically technology developed. Probably even technology is not even developed yet, and a solution can even seen within 3 years, for example, right? But here we're talking in terms of how do you build solution for the bigger agenda, right? For example, we have this example of the gallium nitride program, right? Where when the industry, electronics, LED was sitting down together, said, in order to grow the Malaysian economy, or Malaysian standing in the LED market, solid state lighting, you must form this, we must work in this area called epitaxy, where we don't have in Malaysia back then, right? Not in 2012, 2014. It's basically the decision to say, let's invest on this. How do you build learn from the expert in the US, build similar kind of capability in Malaysia, and now you can build the next, kind of a downstream product, right? You go from TRL 3 to 7 with multiple applications. So these are the three approaches that I think, in terms of framework for industry academic collaboration. You can choose to be, one or the other, but at the end of the day, it's all about how do you take your technology, your concept closer to market, and it has to be done with the industry partner that has access to market, right? So if that's not the case, then your journey to taking your concept to prototype into a real product that a customer will buy will not happen. It will take a much longer journey. So maybe I'll just stop there, and then and we can move on to the next so-called set of questions. Yeah, thank you.
Thank you. Thank you for providing the overview of options and your experience in the matter. I will now move on to Dr. Helena. Dr. Helena, it is a wonderful opportunity to have you speak on behalf of FMM, the voice of the largest private sector economic organization in Malaysia. We would like to take this opportunity to know more about the Federation of Malaysian Manufacturers, and what are your views in having local grown research-based innovation? What are your views on companies collaborating with innovators to drive the nation's economy?
Thank you, Dr. Wan Fazlida, fellow panelists, Dr. NorAzmi, Alias, and Professor Dr. Samsilah, Roslan, fellow participants of today. I'm sure many people are very curious about FMM, because FMM has been very much in the public eye over the past 2 years, especially the pandemic period. To introduce FMM, I will just briefly do a brief introduction, because otherwise it will take up the 6 minutes. As a premier industry organization in Malaysia, the Federation of Malaysian Manufacturers, FMM, has been officially recognized and acknowledged as the voice of the industry. Established in 1968, FMM now represents the interests of over 11,300 members, 3,500 direct members, and 7,800 indirect members from the manufacturing supply chain. FMM's vision is making Malaysian industries globally competitive. As such, a key focus is advocating the interests of industry to ensure an environment conducive for investment and trade by organizing programs aimed to enhance the capacity, competitiveness, and business opportunities for Malaysian manufacturing sector. During the 18-month-long COVID-19 pandemic and lockdown, where many manufacturers were closed or operating at smaller capacity, FMM played an important role to update and assist members with advisories on the most immediate updates on the latest ever-changing SOPs from the relevant authorities and agencies to avoid any violations to new regulations being put up, mitigating the impact and spread of the related virus in the manufacturing premises. That is just a brief overview of what FMM is. To answer your question, manufacturers, innovations become the lifeline for sustainability at the first instance, followed by the impetus for expansion and growth. Innovations help manufacturers to stay ahead of competition by adding value for their businesses, adapt, evolve, and grow through disruptions. Which is disruptions is a dreaded word by many manufacturers, because many companies have to close due to disruptions and innovations, and the obsolescence of many products and technologies. Also, increased chances to react to changes and discover new opportunities. However, it is a rough ride and tough journey for the majority of the industry due to various factors which hopefully can be overcome in time. There are so many new innovations being developed in advanced countries. One such awesome innovations to the computers is the quantum computing, which can run 100 times faster than the current computer system we are now currently using. China is using quantum computers at a massive scale. Hence, their 5G and 6G usage is causing breathtaking innovations to happen, which we here in Malaysia can only get at now. And on the horizon, coming is another new, extremely amazing use of graphene. This graphene can be nanolized and compacted to produce microchips to make computers, which will be 1,000 times faster. Can you try to imagine the impact of such innovation? The possibility is really mind-boggling. Huge developments and innovations based on functional printing over the past 10 years will in the very near future change the world that we now know to an even greater extent. Why I keep on talking about computing and functional printing is because I come from the printing industry, and I have been following closely the development of the printing industry. Moving forward, the printing industry will be enhanced to a very much higher level, whereby many things will be printed, such as PCB boards, batteries, and RFID chips, antennas, and the list goes on as it increases its innovations and inventions. And all this can be printed on flexible materials and even paper. So making the cost of all these chips and RFID and antennas at a very much lower cost. So this will encourage the creativity and inventiveness for a lot of researchers and industries to want to embark on developing new products to harness such amazing technologies, so that dream items or dream gadgets or dream technologies can happen in the very near future. It is unthinkable that the printed electronic technology is advanced to such a rate now. And over the past 10 years, I've been witnessing its rapid advancement, and is now at the commercialization stage. And over the past 5 years, it has turned into, especially from the developed countries, into I think it's into the multi-billions in terms of businesses. So with all this, we can see that cutting-edge products can be developed. So as such, you can see that printing, some say is a sunset industry, but I beg to differ. It is not a sunset industry. It has gone to a much higher level, which many are not aware of yet. So the manufacturing sector contributes about 25% to the GDP and poised to grow further with adoption of digitalization in the end-to-end business and production processes, while innovating the offerings leading towards a high-tech nation. In order to do that, it is urgent now for collaboration with academia for innovations. The tripartite model of government, academia, and industry was set up a few years ago to spearhead this initiative. From my personal interactions with many academia, it can be seen and felt that there is the need, an urgent need or important need to form this alliance with the government's backing. And well, if it can be said, the industry always need the government's hand-holding to work together with the academia, who will provide all the resources for R&D work to develop new innovative product where the industry can capitalize on its market potential. Of course, in business, we always talk about making money. So, and that is most of the time the focal point. But now, given the current situation, we have to add in the environmental factor, and also we need to develop products which can fit into the circular economy.
Okay, thank you, Dr. Helena.
Right.
That's a lot of opportunities and lots of untapped potential collaboration there. I'm sure. I hope the universities will reach out to you more. So my third question now goes to Professor Samsilah. Prof, you have a lot of experience in handling and training tech transfer offices and trade. So you understand the academia to provide a balanced point of view. Perhaps my question here is a general one, but it also aims to make research-based innovators and industry partners understand each other so that they are on the same page and so that meaningful communication and decisions can be made. So please describe the journey for an academic research to find its way to the hands of the society, and where does the industry fit in? When are innovators ready to link up with industrial partners? When is it too late, too early, and when is it too late? Over to you, Prof.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good morning, everyone. Can you hear me clearly?
Yes.
Okay. So when we talk about industry academia collaboration, actually there are already a lot of stories about successful collaborations. What you can see is one example. This whole technology on advanced membrane for hemodialysis treatment, water and wastewater treatment has been developed for quite some time by UTM, Professor Dato' Technologist Dr. Ahmad Fauzi Ismail, and they have actually received quite a number of interest from industry partners. It's one example. However, the questions that people have always asked me is that why is it so difficult for researchers to commercialize their products? So maybe we can backtrack a bit and ask ourselves, you know, do we normally set our mind to commercialize when we embark on any research endeavor? If you ask researchers, I think very small number would say that, you know, I do research because I want to commercialize. So the fact that we are knowledge driven and we're not demand driven is something that we cannot deny. You know, universities are a place where people explore on the fundamentals of knowledge, the frontiers of technology. We assist students to come up with, you know, new research, new discoveries in order to, you know, graduate and so on and so forth. So at that point of time, when we first start on doing our research, normally in our mind, the purpose is because I want to secure research grants, I want to have research projects, and I want to fund my students' research activities, and we want to publish. And if we are lucky, maybe we will end up with some patentable innovations, you know. So very, very seldom we have researchers who, you know, set in their mind at the first, at the start of any research project that, you know, I want to make sure that this innovation from this research is highly commercializable. Although there are already maybe some movements towards that nowadays, but conventionally that's not the case. So we had to, I mean, the group of people in ITMA, we are Innovation and Technology Managers, or more fondly known as ICCs, Innovation and Commercialization Centers in universities. So we had to get researchers to understand why there is a need to be involved in commercialization. And the most common way of explaining is that when you have spent a lot of time to come up with solutions, you want that solution to be mass produced. You want to get as many people as possible to benefit from your solution. And that is why we have to work on commercializing it. We have to find a party that can mass produce the solution. It's not the university's core responsibility to mass produce and manufacture things in high volumes. So we have to get an industry partners, and they will assist us in mass producing the solution so that we can get people to benefit from it. And hopefully this will be accepted as success or impactful result from the R&D funding given to universities. And with that, we will get more funding. So there's a lot of understanding that has to be in place for researchers and for universities. You know, when universities commercialize, they shouldn't think about, you know, making a lot of money from the commercialization itself, because that will kill the business. Worldwide, it is understood that 95% of profit from commercialization will go to the industry. It will spur the economy of the country. Only about 5% goes back to the university, but the university has done its corporate social responsibility and has proven a good track record in utilizing R&D funds, and with that, they should be given more R&D funds. So that's how the thinking should be. Next, I just want to tell a story on this interesting collaboration. So people, maybe just now our wonderful moderator, Associate Professor Dr. Wan asked about when should we start the collaboration. So as early as possible. So this story, this wonderful story came about when Professor Aziz of UPM had this patent on the technology of sterilization using high pressure steam to reduce loss of palm oil in the refinery. So he was stranded at an airport when he was on his way to an international conference, and he sat beside this gentleman from Australia, Mr. Greg, and they had a wonderful discourse on the whole potential of this patent. So, you know, when researchers come up with solutions, they don't come up with products. So there's something that everyone needs to understand. Researchers normally come out with like a solution, a portion of a product, you know, a portion of a complete marketable solution. So they need to talk to people who can give them an idea of how what they have created can be developed into a holistic product. So Professor Aziz actually had this, he said that's the best you know, airport strand that he's ever, you know, come across, because he get to talk to this gentleman and Dolphin International, and ended up licensing this technology from UPM. They became public listed in Australia, and Mr. Greg was very happy that he wanted to get more technologies to develop future palm oil mill next phase. But Dolphin was a bit hesitant, so Mr. Greg actually set up his own company called Fibaloy and took up 6 more technologies. And they have, you know, long story short, you know, they secured grants, scaled up and so on and so forth, and they have installed pilot future palm oil mills in Samsilah and are in the process of, you know, creating or developing more of this type of palm oil mills. So when you start with industry at the early stage, that is the most wonderful and most ideal commercialization story, because you know you get to develop together with industry. The challenge is that at universities, normally we have, you know, completed the whole of our research, our postgraduate students, PhDs, without having industry input. So that can cause some issues and problems later on. Okay, next please. So I can summarize that there are three ways to go to market. One is research partnership, academia industry partnerships. You know, from the start, like I think what CREST is doing is going to be very successful if you work together from the start. You know, like Japan and even Fraunhofer model, they have that kind of collaboration from the start. It's very ideal. However, in order for this to happen, you have to make sure that the industry are ready. That's the issue with industry in Malaysia. Many industries in Malaysia are not ready to adopt high technology. So they cannot partner with university at this early stage. So we are very far from Japan and so on and so forth. So that's why we have to move to the next option, which is to license to industry. But again, when we license the technology to industry, we have to be together with them, exploring the whole process, because again, our industry are not as equipped as like industries in other parts of the world. So the whole effort that researchers have to do to make sure that this industry is able to come up with the end product that is commercializable is enormous. And that requires the university's understanding and the researchers' understanding in terms of, you know, like channeling or having a different track in terms of their career path. And last but not least, perhaps the best form is to have startups. So in situations where industries are not ready to take up, the researchers have to found or become co-founder of startups. So this is what most people are doing in Malaysia now. We form startups, but that is not without its issues and problems. We do have successful stories like Next. This is a startup that is, next please, already selling their product in online platforms as well as pharmacies, you know, because they have the right ingredients in place. So I'll stop at that. Thank you.
Thank you. Thank you, Professor Samsilah, for sharing the successful projects. It helps industry understand the academia and perhaps the academia to understand our own selves as well. Now I'm going back to Dr. NorAzmi. I'm intrigued by your earlier response because I can see that you're implying many things in between what you stated. So my earlier question was on the existing model, but now I'm asking more on possible collaborative model to explore in Malaysia. What are more creative ways in making the partnership work? And how do you think the collaboration should work between innovators and companies in the Malaysian scene?
Thank you for that question, Dr. Wan, and very enlightening session, sharing from both of my panelists, today, Dr. Helena and Dr. Samsilah. Probably what I'm going to mention here also being shared by two other panelists, but I think the way that I see how we can actually get more creative in terms of strike more collaboration and more meaningful collaboration. I'll use the word meaningful collaboration because there can be many collaboration and may not come to impactful kind of outcome, right? So my thought is and I've been doing this even within the organization in Motorola, where I had about 150 different engineers and managers, and as a within the department of mechanical engineering, right, that supports the different businesses, and then we have other group that looking at the so-called the software and on the electrical engineering part, right? And we realized that, if we follow our department kind of a structure, we only focus on our mechanical engineering and the component that are, physical in nature, without interfacing with the other group, we will not be, more creative and not able to innovate solution, better and faster, right? When I call out, for a session with my managers, I say, how do we structure our work, right? Because, I have a group also what we call the technologists and the group that are more of a product development team, right? And these guys typically don't see eye to eye in many ways, because one very focused on build new technology and to come out with the so-called sophisticated way of doing things. The product team, the engineer, the product engineer said, I just want to get the product developed, optimized, design, no problem, and I can ship to the customers. So you see even the two kind of extreme of thinking among the engineers and also the technologists, we call them, in one organization, right? It makes it even worse when there are, you have to create product, you have to, interface with the different group of people from the so-called the business, from the, software group, from the, electrical group, right? So for me, the only way to move forward and be more innovative and creative is you have to be part of a bigger agenda, right? If you are a chemist, if you are a biologist and whatnot, you have to actually find a collaboration platform, I call them, or an entity that will bring the different ideas together that has all the elements from the industry. It must have the industry element in that platform, right? Otherwise, you will not know where to who to look for, which company to for you to knock on the door, right? We get examples of one of the professor in material science and also in physics, knock on the door of all different companies in Penang, because he wants to say, I want to collaborate with you, right? Some shut the door, some open the door, but it's very painful exercise, right? So you don't want to go and keep knocking on every door, 10 doors, per day, and in a week you retire after doing that, right? And you get frustrated. So be creative and be part of attend the different group that are addressing either a particular market or a particular technology. Like for example, you have in this case, CREST. We were formed to look in terms. In fact, many people don't know this, right? The story behind why CREST was formed is not because we just like to have this the platform together. It was a pinpoint that was drawn to say what happened if all these big name companies decide to leave Malaysia one day. What happened, right? And because it was the 2010, 2011 kind of setting. I think the industry was the electronic industry was a bit stagnant in terms of growth. It's not very high growth. And big companies like Motorola, Intel was given a question: what happened if you cannot do what you want to do next in Malaysia? What happened if you cannot have the right talent actually to do your next generation product and solution? What happened if you cannot collaborate with the academia who actually maybe want to look more of a blue sky kind of research, but not try to see how they can help to solve a problem from the industry? So we said, okay, that cannot be, because if you put all these big 7 companies together, Motorola, Intel, Altera, Agilent, and all that, Osram, etc. If this company leaves the country, not just they will leave, the employee, which is a Malaysian, will leave the country, right? So it's a brain drain problem that we're trying to so-called mitigate and do a so-called preemptive kind of a strategy so that it doesn't happen, right? From taking as a problem, now you see as an opportunity. So what if you can now bring the different parties together, the industry, academia, the multinationals, the SME, and perhaps even the government to come to say, can we put a framework to see how we can move the industry together, right? And now you see, it can also be along the line of a technology like Nano Malaysia, looking at purely on nanotechnology, carbon nanotubes, nano, so-called surfaces, and everything about the small, features that can create, a more interesting solution, right? And you got MPLC focused on online gas solution. We got now iConnect, health and wellness iConnect, Industry 4.0, halal, manufacturing, Islamic fintech. And even now you see Malaysia, MPC, Malaysia Productivity, Corporation, have their own nexus, right? Along the line of different sectors. And these are the entity that all researcher must be part of. They have to pick which one should I be part of, right? So that you don't have to go become, you have to do all the work yourself, because all this work has been done in terms of defining what are the big problems to solve, what are the so-called the next 5 years, 10 years direction of the industry. And there you go. You don't have to go and do your own Google search. I need to look for the report. You go there and network with the people that are within the so-called this platform, and you understand what they are looking for, right? For like CREST, for example, we do twice a year, call for collaboration. We spell out these are the area, right? The area that we're looking for solution. These are the technology there are gaps and opportunity for co-development with the industry partners, and that will drive the so-called the research, right? The research could be the applied research, could be also the kind of a translational research in terms of making into prototype. And we see that this example, when we first started, we don't know some of this organization like Innovation Foundation, ARTC, exist, that are doing similar kind of structure. And it's been proven in other countries as well, in other sectors, like for example, Innovation Foundation in Denmark, they only focus bioresources, right? And they basically have the framework of industry, academia, the government coming together and defining what needs to be done to actually, address the needs of the, bigger, so-called agenda, right? And common goals. And you will create a lot more, activities, spillover activities. And the beauty of this, you get the whole value chain from research to prototyping, to a product, parts development, to manufacturing, to market users in the same group, right? And these are the part where our innovators and researchers has to be very creative. Even the so-called the industry partners, if they are part of this platform, you get access to all these researchers as well. So I hope I can address the question posted by Dr. Wan. Thank you. Yeah.
Thank you for sharing the vision and the insight, Dr. NorAzmi. I wish we had more time on that topic, but I'll have to move to Dr. Helena. Dr. Helena, now that we have listened to all the panelists, we can I can conclude for sure that everyone's on the same page, having the same vision, with a lot of initiatives and incentives around to help the process become successful. The vision of an advanced nation driven by innovation is common to both researchers and industries, yet we don't see partnerships taking off as we would like to see it. Prof. Samsilah has shared successful projects, but it should be more, right? So I don't mean to put forward a negative question here, but perhaps it's a good tackle to issue. It's good issue to tackle. So why do many collaborations fail to take off?
Yeah, this is a very good question, which is on many of us business association, especially. Why is it so difficult to collaborate with the universities and all that? Before I go on, this photo is supposed to be in my first introduction of FMM. This is the picture of the all the council members, the current council members, just to give you an idea of who we are. Okay, to give a background on the Malaysian companies, manufacturers especially, I'd like to share a little bit of a story. So since its independence in 1957, Malaysian government has successfully promoted the manufacturing sector, diversifying from its agriculture-based economy and as a means of generating employment opportunities. Growth of the manufacturing sector was rapid, and many foreign direct investments bring in new technologies and expertise which grow over the decades to become big conglomerates here, at the same time spawning many or numerous small enterprises in the supply chain, providing the necessary support and infrastructure. This gave birth to a huge number of SMEs, small, medium industries, who traditionally developed their business by learning from their previous employers. They started small and some grow sizably. Many did not, many did very well, and their business model is very simple. importing component parts and either blend or assemble them into finished products. Therefore, there's no R&D enlisted here. All that was needed was quality assurance of the products that they produce. So this has gone on for a few decades until we say the comfort sets in, and because the culture of not innovating their businesses or their products led to saturation or obsolescence of their technologies. So along the way, companies close down when they cannot upskill, update, and upgrade their technologies. So this you can see that this is the background of why many companies, they do not understand the importance of R&D. And at the same time, many industries or manufacturers fear. They have this fear about to put themselves into conducting R&D, because this is an area which is alien and very foreign to them, and they do not understand how to undertake such activities. And with the onset of globalization, it makes matters worse, because the demands for certifications and standards come into play more and more, and it's squeezing out many companies who still refuse to improve their circumstances. Of course, on the other hand, there are many companies who see the need to be innovative, to invest in R&D, to collaborate with the universities, to work together with institutions to enhance their product. And this is where many hiccups or many factors come into place. I'd like to share some of the factors that or reasons which both parties may face. First is on the part of academia. Of course, there are many researchers and R&D being carried out. Of course, there are certain products which have been developed, but most of the time, after I speak to numerous universities, most of the time, all these research, completed research, are put into the archives and never seen the light of the day. So on the one hand, the industries are scared to go into R&D, and the R&D institutions have got nice product, and they put it into their beautiful shelves. So the two parallels never meet. Hence, we have got to change this. The academy have to open up and pull in the industries, those who are willing as a low-hanging fruits, so that we can move forward together. So the trust factor is another very important area where many times the projects fail, because along the way we need to be open and be sincere in many of our sharing of technologies and capabilities and findings. And with sincerity and trust on both parties, I believe the coming together of industry and academy will be faster. At the same time, of course, there are always expectations on both sides. The academia will always say the industries no, they are not ready, or they are not cooperative. And on the other hand, the industries will say that the researchers are not open enough with their findings, then they should not share enough with us. And then, I mean, all these misunderstandings which can be ironed out. These are small things, but it's a deterrent to the collaborations within the industry and academia. And also from the industry side, speed is very important. Speed is of essence, because in business, when any activities or any projects that we do or we put our efforts in, we want to see monetization. Of course, we want to see some ROI, in other words, the buzzword ROI, return of investment, to bear fruits. So in this way, it is important that both party has to work at the desired speed in order to see the actualization of the innovation. I'd like to share with you my personal experience. A few years ago, I wanted to partner with a research institute for a very interesting product which they have developed. And I wanted to commercialize it. Of course, they have to open up with their product information, the components, and its salient points, its then so that we as the commercialization partner will need to have all these information to develop our marketing strategy, our product brochures. Whether we put it on the shelf or we put it online, we need to have a lot of information from the researchers in order to make the product so desirable that it can be sold quickly. And then I was going fine, then came the stumbling block, because this is a skin, this is a antifungal skin product to be used on the skin. Therefore, certification is very important, and the certification needs 5 to 10 years to obtain. So this is the stumbling block. So we just abort the whole project. At the same time, the cost of acquisition is also very, very exorbitant. And these are the factors that we find that we need to come to a point where we need to work on issues like this, especially on the government side. The certification process need to be quickened at a faster pace, because 5 to 10 years is a no-no, because by the time the certification come out, the product could be obsoleted, because the development of so much new raw materials is coming up almost every day, and in 5 to 10 years time, maybe the material used is already obsoleted, or if new findings may deem the components of that product as unsafe for human use. So these are the things that is happening currently in the market. And this is a very good forum where both sides understand each other, the academia and the industry understand each other, and we sit down and come up to the drawing board to set up certain working procedures where both sides can work together in harmony. At the same time, the ultimate aim is to realize the commercialization of the innovations that has been developed.
Thank you, Dr. Helena. Thank you for laying it out on the table. And as a follow-up to what was put forward to Dr. Helena, I'm moving to Professor Samsilah. I would think it is also good to hear from a similar angle from you. What are challenges and limitations of academic researchers in going through the commercialization journey that so many of us don't take off? And what should academic researchers know when engaging with companies? Thank you.
Okay, there are several challenges that normally researchers encounter, but mostly it's because we do not have a manual on how to go about doing this. Like, what do I do? Who do I talk to? And what are the things that they are asking me? When industry ask researchers, a lot of the things industry are asking are not being, they are not within the vocabulary of our day-to-day scientific discourse. So it's not something that is, we can understand very easily. So the whole thing is, I can summarize like in 4 challenges. The first one is, when we come up with a solution, very unlikely we already have the value chain in mind. So we don't study from the start, how will I integrate this solution into the existing value chain? So we did not think about the cost, we did not think about the for example, supply of raw material. We did not think about, logistics and things like that. We just come up with the best solution that we can. So now we have to integrate the solution. And then another issue is that when we have that kind of solution, again, I would like to stress, we just have a solution that is not an end product. It's just a technology, but we do not know what kind of product that is best and most marketable that we can create from this technology. So I give an example. There was this technology, a patent on halal gelatin from plant source. So the researchers said that perhaps I can, we can approach, we can come up with a business on producing capsules from this halal gelatin from plant source. So the wonderful thing is where I worked, at the place where I worked was at Putra Science Park. We have this Hub where we do market validation, which means that we have a platform where there's a team, there's a project manager from, young entrepreneurs who are being coached to conduct this market validation. So when they ask around and they map it on a business model canvas, they realize that, the whole business, if you are solely focusing on producing capsule from halal gelatin, you need huge capital and the profit margin is small and the market, it's not easy to secure and the volume that will give enough return for you to sustain the business, So in a nutshell, perhaps that's not the best way to go to market with this technology. So they explored and see that, perhaps we can do micro encapsulation of animal feed, So when people give their livestock the feed, they also want to give some like antibiotics or prebiotics. So we can encapsulate the feed together with the prebiotics, using this halal gelatin. But when they go and ask farmers and also the association, they found that this is not something that the farmers want, because they say that the price of animal feed fluctuates so much because of the currency exchange, and a lot of ingredients are being imported anyway. So and they don't want us to encapsulate together with the probiotics, because if this ingredient goes high in the market, they can replace it with something else. So from there, they stumble upon this idea of, maybe this halal gelatin, we can turn it into animal feed, since animal feed is so expensive. And they found a way to actually feed worms with this gelatin, and the worm became very nutritious and they grow very fast and they become a very nutritious food for livestock. So based on this model, and they've come up with a business model and so on and so forth, the startup was launched and it became quite successful. So you can see how they pivoted from the original idea to the product that is finally will make it to market. But you need a program where you can do all this without having to spend money first, invest, and then found out that you have failed. So you fail on paper, and then you will come up with the best solution. And also another challenge is that I have mentioned just now, researchers are employees of universities, which means that they are subject to the ecosystem in the university, the legal, the financial, the governance framework. And this is very different. This whole framework, they are very different from the business framework. So a lot of our procedures, especially financial procedures, are very, very slow because we are subject to tax and regulations by Ministry of Finance. And this does not go down well with our business entity because they need to move very fast. So that becomes an issue. And universities, although they are given autonomy, they still have to formulate a certain framework where researchers being paid with tax-based money can work for industry. So, but you still have to have that framework in place, or else it becomes an issue. Okay. And also mismatch, a lot of mismatch expectations. Again, I have mentioned universities cannot, from the start think that when we commercialize something, we must get a lot of returns. There's worldwide, there's very, if Stanford, there's really three successful, really successful commercialization project from the whole of their commercialized products. So a lot of mismatched expectations has to be managed. So that is where technology transfer professionals come into a picture. So everywhere in the world, when there is this kind of technology transfer from one entity, the university, to the business entity, the technology transfer professional will be there to advise both parties to mitigate all these issues. Next. So what's important now, next please, is we need to also understand that different disciplines have different backlists, have different journey to market. So biotech and life sciences have certain regulatory procedures, they have scaling up and optimization processes, and might need to take like 6 to 7 years before they can go to market. So companies that want to be involved in this kind of products need to understand this as well, as compared to perhaps ICT and social sciences. They don't have to scale up, they don't have to spend so much on the, getting regulatory approval and so on and so forth. So it is different between case by case basis. And next, at the end of the day, we need to know why we have to do this. We have to do this because Malaysia economy is not good. We have not really realized our full potential. Our technology adoption is still very low. And next, majority of the companies in Malaysia are SMEs, 98.5%. 89.2% are in services. So we need to, but I believe the government has already come up with lots of enablers in place to make sure that we are able to fully utilize the potentials of our innovations to contribute towards the economic growth of the country. And lastly, next, we want to be able to show this kind of metrics to people in terms of the impact of our economy in, for example, creating jobs, the value in the problem solved, startups created, and so on and so forth. So at the end of the day, it involves everyone in the whole ecosystem being on the same page. I think that's the most important thing that we need to do. We need to get everyone to understand the whole purpose of this effort and the challenges and how to go about overcoming them. Thank you.
Okay, thank you, Professor Samsilah, for giving a very realistic point of view for the audience. I'm going to jump to Dr. Helena next before I go back to Dr. NorAzmi. Dr. Helena, we have factored in this question so that we understand how companies think as well in general, as well as considering current situations. And you mentioned this a little bit in your earlier response as well. So what do companies want and expect out of innovative collaboration? What sort of contribution are companies ready to pour into building a collaborative innovation? And in these difficult times of the economy due to the pandemic, what is expected?
Yeah, these are three very pertinent questions. To answer the first one, what company wants to achieve out of the innovative collaboration is to see their products enhancement after the collaboration efforts be able to scale up to the market at the fastest possible way. As the saying in the business world goes, time is money. Companies also want to see the ability to bring to life new innovations in line with the latest technological trend and to able to go to market in all readiness. Again, in the business world, there is another popular saying, early bird catches the worm. Okay, of course, all innovations must be in line with meeting the protection of the environment in the ecosystem. And especially good will be if the products fit the circular economy. The next question, what sorts of elements a company related upon into building a collaborative innovation? Once a company has identified the university they wish to work with, it will by all rights provide the full cooperations. I would say that it is best to work as share resources. What I mean is that the industry should invite the researchers into their manufacturing premises and develop product jointly. By as the process goes, researchers can use the resources of the manufacturing to see whether what they are working on is the right direction, and also at the same time they can test at a various level of the development of the innovation. So this is one area which more and more industry are opening up to these shared resources. And of course, once an innovative product is confirmed to be an amazing product fit for the market, which will be the desired product for the market, the industry or the company concerned will take the risk to obtain bank loans to finance this product. Of course, the incremental improvements of existing product and the creation of entirely new products and services of prototyping accelerates the process of determining whether an idea should be pursued or discarded. And I can see that if these shared resources will be put into more practice, the deciding factor of whether a product should be pursued or discarded at early stages will happen at a faster rate, so that efforts will not be wasted. Efforts and resources will not be wasted on an idea or a prototype that doesn't work. Okay, and then the last question is a very interesting one. In these difficult times of the economy due to the pandemic, what is expected? I can tell you, this 18 months long, all the businesses had a very rude wake-up call. Okay, I have been receiving calls from my business friends that say that those that have that are overseas what do you call the investment in Malaysia, many of them want to pull out because the lockdown was too long, and then even some of them were able to operate, but then along the supply chain there was disruption because some of the supply chain they're not able to operate, and there was so much tension and so much problems that for the manufacturers that they are not able to proceed. And at the same time also, as Dr. NorAzmi said just now, the MNCs, overseas the company that have huge investment here, such as Intel, if they decide to pull out, what happened? There will be huge vacuum. There will be huge vacuum. What are we going to do? So this is another wake-up call for all of us. We need to address all such factors immediately. It is very urgent because if in fact many big companies have threatened. Of course, we have heard about this. The Euro Chamber of Commerce has come up together with various other European channels that say that if Malaysia doesn't improve on its policies and regulations, especially in handling the pandemic, they threaten to pull out. So that is something which frightened many of us, and we have to sit up. Actually, we sat up and thought about it. We need to do something more. We need to really go into innovation. We need to look into new product development. We need to own the technologies that's being used now. We don't depend on others. So this is something which which we need to really take deep into consideration. And at the same time, it's so important that we put more effort to work together. And I think I still strongly feel that the government, the academia, and industry must work very closely together, and very fast. We need to move forward in order that we are able to sustain ourselves in the long term. We want to go into high-tech nation, but in the first place, we must look inwards and see whether do we own any of the high-tech technologies. If we don't own any of the high-tech technologies, we cannot call ourselves a high-tech nation. We must own it. So we depend very much on the academias, the researchers, to work fast and furious and hard, and please pull us industry into your group so that we work together, so that we will be able to really own the high-tech technologies in Malaysia and be proud, be a proud nation of our own technologies. This is all I have to share. Thank you.
Wow, thank you, Dr. Helena. It's good to hear directly from the voice of the organization on the matter itself. Okay, so I'm going to Dr. NorAzmi now. Dr. NorAzmi, with your vast experience engaging many universities through CREST, I would really like to hear your thoughts on this. What are important points for both sides to understand of each other when engaged in a collaborative model for an innovation? How do we foster successful industry-academia collaboration?
Thank you, Dr. Wan. Before I go to your specific question, I was going through the chat. I think so Dr. Rose Jadi Norden from UTM was asking in terms of what are some of the challenges and issues in the actual collaboration, because what CREST has fostered, we have fostered about more than 160 different collaborative projects, and I've seen all sort of behavior, if you wish, the kind of those are really come to the table of the discussion through collaboration. Some are really want to collaborate, just look nice on paper, said we are collaborating, but when we come to the progress review or not, they actually throwing the question to one side of the table and then expect the answers, and using the session that we call them out for them to actually review their progress, right? And those are some of the challenges, and also the expectation need to be spelled out very clearly up front. So it sounds very academic what I'm putting up here, but these are some basic questions to ask ourselves for researcher, even for us when CREST looking in terms of what area we want to drive in the particular industry or in particular technology. We have to start with the why. Why are we doing this? I think this is a basic question that we're also asking a lot of our talent program in the boot camps, and also in hackathon. What are you trying to solve? Why are you doing this, right? And it's the same question we should apply to researcher. The same question we should apply to the industry. Why are you coming to us? And why you want this to solve this problem for you? What's in it for you, right? And I think when you look in terms of what's problem to solve, I think then you will realize in terms of what will be the benefit to both parties, right? When you do the industry academic collaboration, academia has the so-called the requirement to produce more talent, to produce more postgraduate masters and PhDs, to produce new scientific discovery, to produce scientific papers, and along the line, if it's patentable, to create IP and commercialize them, right? And those are the so-called the benefit, the benefit or the requirement that industry must understand. But on the academic side, they need to understand that industry wants the problem to be solved yesterday. so the kind of urgency that the industry are looking for, I don't want you to do a very long-term scientific study and discovery or whatnot, but not solving my problem, right? But I need to get whatever technology that you can create within a short period of time. Can I take that technology and then put it into my product, and then they go solve my problem, or create a new feature in my existing product or in my new product? And that's what I'm looking for. So this kind of a very so-called contradicting kind of a requirement need to be understood by both parties, because if you don't understand that, and yet we have one example where they try to develop new materials or polymer, in one extent, to improve the optical properties for optical switch, right? So the end product will be optical switch to be used in the electronic, product, but the research requires that a polymer to be developed first, to be synthesized, and you know how many steps that is, right? Synthesizing polymer to make sure it's meeting all the performance requirement, make sure it's stable, it can be processed repeatedly and then consistently, batch after batch. Then only you can go into now, can we make a working prototype that industry will accept? So the researcher could not understand that if you don't meet the main criteria of the performance, the project cannot go, cannot proceed further, right? So there was a requirement given by the industry that you first have to meet this requirement and single-handedly written down these are the requirements before we move to the next step. So and there was challenges, by the researcher, and basically we decide, to a point that okay, in order for us to continue for the research, we will no longer will make into collaborative project, because industry said, I'm giving you enough time, you cannot come up with the solution that I'm looking for. Therefore, we had to terminate this collaboration, right? So that's the part the industry need to understand, the academy have to understand that industry looking for a solution. They're looking for something that are within a window of 12 to 18 months. They don't look for a window for 3 years, right? If looking for a window of 3 years, then they must looking at some basic IP you need to create. Then I'll have a second round of a project that coming out, right? So that's more like a 5-year window product kind of horizon. If they're looking for a window of 1 to 2 years for a horizon, they need to be solved yesterday. I mean, just a kind of in a manner speaking, the sense of urgency has to be there. So it will not be a research project. It will be more like a contract engineering work, right? So the nature of collaboration also need to be clearly spelled out. Is it co-development, like Dr. Samsilah was talking about, where they come to a process, we need to co-develop the technology, then the prototype, then product in the market, and that require stamina, right? Stamina, and also in terms of strong trust in each other that okay, whatever problem that we have, we will work together on this. And when the two parties doesn't see eye to eye, do not understand each other, sometimes this is where what CREST have done is we facilitate. It's a tough discussion, right? Okay, I cannot achieve this particular milestone because it has the requirement. Do you allow us to go back and therefore we may have to delay our end so-called end date of the project. So we have to agree to that, to say before we talk about other milestone, let's go and solve this problem first. So they require the extension of come up with new solution and give them ample time, and we make a criteria. So so these are the nature of what the collaboration has to be, the end game. If the end game is about making a product that are in a system of product, that will be the case, right? And sometimes these are not agreed, very vague in terms of writing out the so-called proposal. Even when they go into an agreement, what CREST does, we need to make sure that they both agree on the end goal, right? And this is the discussion both ways. It sometimes can be quite painful, and there are cases that project did not move to the execution stage because we cannot agree on the terms, right? And and again, in order to take into successful collaboration, everything has to be so-called threshed up front. Everything has to be discussed up front. What are your expectations? What do you want to get from this? What's in it for the industry? What's in it for the academia? But for me, once you get through all that basics, those are still the basics, right? In terms of to get a successful collaboration. But I'm trying to move in terms of, okay, let's not look at one project at a time, right? Because we should move beyond one project at a time. As a researcher, you want to see, okay, I'll be successful with this project with Motorola, with Dyson, with Intel, and so on, for example, right? Can I take that, IP further? Can I, enable myself to actually secure more projects from other like-minded companies? I'll give one example, the project I mentioned earlier between USM, the vibration lab, Prof. Zaidi, and Motorola, right? From that project, they create new capability in terms of wind tunnel, do a wind simulation and whatnot. And those are some basic issues that are, many, a company with product that has motor or has any kind of a electronic system will create noise, vibration. And when we sit down to say, okay, Prof, I think you have something good here where a lot of product in the market has this problem, right? And, then we together agree that from this project, we can make known to other people that USM, the provision that has this capability, for example. And, and good thing that, Prof's idea also becomes own marketing, right? He's a good marketer now and has own website, own conferences, open day with the industry to tell people what he has done with that one project that started with Motorola and then later on he got another project, Dyson. And they say, this is my strength. Now I can build my, collaboration with a bigger, so-called number of company, wider scope of the market, with the expertise that I have, with the lab that can serve the entire industry, right? And it will create new possibility. Could be project, could be engineering services, could be training, right? And this is again when you are going to one project, think beyond what do I want to get after that project complete, not just I want to just finish this project and done with it, right? So from an academic point of view, you need to go beyond thinking about I need to do more than what I'm looking at in front of me right now, right? And I think that will drive you to say I need to be successful here so that I can create more future references, future projects and whatnot. So that kind of a little bit of a recipe, I will call them, a question to ask on both sides, the industry and academia, so that at the end of the project you're successful with what you are working on, but it's open up new doors for new possibilities. Yeah, thank you.
Okay. I will now get back to Professor Samsilah for the final question. And this question is crucial towards building trust and strengthening partnerships. How do researchers safeguard their interests? And how do technology transfer professionals assist the commercialization process in building this trust? Thank you.
Thank you. So I would like to concur with my fellow panelists just now that Helena mentioned about misunderstandings that occur between the two parties, and Dr. NorAzmi mentioned about lots of dispute management or trying to negotiate and get people to understand. So that's I believe a lot of problems and issues that occur is actually caused by the lack of understanding of and misunderstanding certain things. When researchers embark on this technology on this commercialization process and they work with certain industry, there will always be all these so-called unpaid advisors, independent advisors, telling them things like, be careful, the industry will take you for a ride, it happened like this, and they will cite certain stories, and then they will tell researchers that the industry is paying you so cheap. You see, in the industry, they quote certain quantum, so it makes the researcher very anxious, and then the issue with IP again. IP is very important for universities because IP is the legal document that shows that we own certain technology and we have the right to continue working on that technology. So especially, pursuing research, getting more students to work on it and further develop it. So IPs are important. So if we don't manage this misunderstanding well, that is when collaborations will fall apart. So that is why you need technology transfer professionals, because they know how to explain. They should know, they are being trained on how to properly explain things. If the market value for this technology is certain amount and the industry is paying you certain amount that is very much lower, why? You have to explain. You have to put on the table the investment the company is putting in, for example, in the development, the stage of readiness that your technology is at now. And if you don't get that investment, it will not move forward. So you have to explain in that way. For example, another, I have received this before, industry complaining to me that researchers are not responding to their, they are very anxious because they need researchers to handle some troubleshooting issues with, the technology, and researchers are not responding. And researchers say that, they are being overwhelmed by the company's persistent, requests for them to work and on helping the industry when they have classes to teach and they have, other things to do. So that is why from the start, we have learned from our experience to table the whole blueprint of the technology development. What are the activities that will be, conducted? Who will do what, when, and then, you get everyone to understand. And I also tell researchers, tell industries that our researchers are not like their full-time technical experts, because our researchers are working at the university. Unless there's some critical period where they need the researchers to be at the company full-time, then it is a separate arrangement that we have to do with the university. So there are things that technology transfer professionals can assist because they have experience and they know from their discussions within their network, and they are already trained to do all these things. And that is why I always advise researchers when they work with industry, regardless of, especially if it's through technology transfer or through startup, to have technology transfer professionals together with them from the start. In fact, it is a practice worldwide that when a researcher has a discovery, they will do invention disclosure first, and the technology transfer professional will evaluate based on the invention disclosure how to go about working on the commercialization path for this particular discovery up till the end. So that is why I think it's very important, again, for researchers to talk to the technology transfer professionals in your university, or go straight away to ITMA if you're not sure. The 5 research universities in Malaysia have each, I think, commercialized more than 100 technologies. They are very experienced and they can assist researchers. Next, please. So ITMA, this association, is set up to help train technology transfer professionals, although we are being faced with this challenge of high turnover rate. But we are still working very hard to get as many registered technology transfer professionals. We are the only association in this region that is being accredited by Alliance of Technology Transfer Professionals worldwide, that include Autumn. So Autumn is in the US. It's a very highly established association of university technology managers, and we do a lot of trainings for technology transfer professionals. Next, please. And technology transfer professionals can also assist you, both parties, the researchers and the industry, to take advantage of all the incentives that the country has actually put in place. Because it is already very clear to our country that we have to support. I think that I've been involved in a lot of engagements with people who come up with all these guidelines and policies, and I have actually voiced out all the issues and problems and challenges, and they know that the government has to give a lot of incentive to help us enhance or to help push the whole process of commercialization of innovation. So there are a lot of incentives in place, and technology transfer professionals can help channel you to the incentives that you can probably apply and get. Next. Also, there's a lot of next, please. There's a lot of agencies in Malaysia that are supporting our what we are doing. There's a lot of agencies supporting at different stages, doing different things. And just recently, I think Dr. NorAzmi is also part of this magnet that is being initiated by MIGHT. There are 6 founding members that involve include CREST and ITMA. And all together, all of us, what we're trying to do is we will assist and we will handhold and we will give advice, and we will give lots of financial assistance to help researchers and industries come up with successful commercialization from university innovation. So it is the right time for everyone to work together. We need to listen to technology transfer professionals. If you are researchers from university, please listen to technology transfer professionals. If you're not clear about things, ask them. Ask ITMA, ask all these advisors. And if you are industries, please come and work with us at the university. I think we are just as clueless, so we need to work together with you in order to find the best way to best go-to-market plan for the innovations that we have. And that apart from all this, there are certain industry in Malaysia that already have like a very comprehensive platform. Next, for example, the halal industry. The halal industry, has a very, I can say, a comprehensive ecosystem to support what they have. So if you are working in halal industry, look up this ecosystem and find out how they can assist you. So I do not know if other countries have something as supportive as what Malaysia has. So if we do not make use of all these incentives and support and training and handholding in place, I think kita rugilah. We are not utilizing what we have. Okay, so at the end of the day, we hope that with all this collaboration, we will finally be able to transfer as many solutions as possible from the university and research institutes to the industry and the community. Thank you.
This is really very valuable sharing from Professor Samsilah, and that was valuable insight from all our panelists actually. So this session will be available on YouTube recording. So if anybody is interested, this video can be watched later. I wish we had more time to tackle more questions with the panelists. Someone just texted me commenting that some of the questions should be a topic for a talk itself. So we shall now be receiving questions from audience. I have taken down question from Rosdiadi Nordin. Often case, the journey to commercialize is not straightforward. So plenty of internal, external challenges. What's the best strategies to deal with it? Appreciate if you can share actual examples from Malaysia. Maybe I should pass this to Prof. Samsilah.
So I've mentioned just now, work closely with your technology transfer professional in your university because they can advise you, they can find sources to advise you in overcoming the problems. But I think what's most important is to have that readiness in terms of mindset. When you embark on this journey, you must know that this journey is very challenging. There's going to be a lot of problems along the way, and you might fail, after you've put a lot of effort. So make failure your friend. Don't feel that, or don't think that you're not going to fail. There are a lot of failures in doing this, and I've learned from my friends in Silicon Valley that when they look for entrepreneurs, they look for people who have failed in many businesses and still persist throughout. They don't look for people who continuously are successful in doing what they're doing, because when you fail and you continue, you learn from what you failed and you continue doing it, that shows that you have that quality that we need to commercialize and to make this work successful. So some people just enjoy challenges. So if you can change the way you perceive things and make this like a game that, you know, a challenge that you want to overcome, and you want to work together with your friends in you know, getting to where you aim to be, then I think it will be a very enjoyable journey.
Dr. NorAzmi, would you like to contribute on this?
Yeah, I think I can hold myself back to use the clause people saying fail a lot fast fail early because this is typical for researcher, and I used to be one too, right? We're looking for, we strive for perfection, so we won't disclose anything, we won't present anything once until we get the perfect so-called result from our research, right? But when you go into commercialization, try to build a product, you need to do a lot of prototyping and it's not nice to call it trial and error, but I think you come up with the different ideas and you build and you test, and then you go back to drawing board and say let's approach this angle, that angle. So the approach of of startup or in the product development so-called terminology of try to do all the work, take one full product and chunk it down to small pieces, do many different system work and get it to fail, and which one that works, and then become your next step to put all together again. So and you're right, the journey to commercialization is not an easy path. I've done personally myself, I've gone through it. Even you get to the market, you know that you have to go back to the drawing board because the product you have in the market is never perfect, right? So when customers say yes because you work on your first product based on the first customer, but then you go to the second, third, fourth customer, you get all 5 different so-called requirements. So it's never perfect, never but like Dr. Shaliza was talking about, be ready to accept criticism, take failures and make failure as your friend, and but build and rebuild yourself from those so-called challenges. Yeah.
Okay, thank you. I'm going on to the next question, Professor Dr. Ma'an Al-Khatib, and he mentions that in Malaysia, the contribution to R&D is about 1.3% of GDP. How much does the industry contribute to R&D in percentage from this amount? I don't know who would like to take this up.
I don't have the stat, probably Prof. We'll have that.
Prof. Samsilah, yeah.
But maybe I just add, I think from the industry that I work with, I mean, I was from chemical industry before I rejoined back to Motorola. Even some of the big corporation in the chemical, they went to double digits of from their revenue into R&D, right? Because they believe in and these are all big multinationals. I think I'm not sure what are the numbers for Malaysian companies. I guess when you aggregate all these numbers from big corporation and local, then therefore the numbers are very small, right? And I think I also see that the local company are not very keen on investing back to R&D because they worry more in terms of producing a product and look at the bottom line. So I'll stop there. Maybe Prof. Samsilah will have more to offer there. Yeah.
Yeah. If you look at WCY 2019 report, it's 0.81% out of GDP. But maybe Dr. Helena has more information. Yeah.
This is a very interesting question. I would say that from the industry, especially SMEs, it is a zero. It's a zero allocation for R&D. Any allocation will be on ad hoc basis. Yeah. So most of the training or small R&Ds maybe from the HRDF funds. That's all. So I believe this has to change for SMEs, especially if they want to still stay in business, and for long term, we need to really think about investment. Actually, I have started allocating for R&D for my company because I mean, being into these various sharing forums, I myself deeply understand the impact of R&D is so important to the businesses. Yeah. So right now, the answer is I think there's nothing being allocated for the moment.
All right, thank you for the response. Next question is from Rosita binti Dola, UTM Razak School, and she mentioned about brain drain and technology drain. Others will pick up our technology and we'll just be the follower. How do we overcome this from getting worse?
Okay, so it's a brain drain question. It's always going to be a question, when people are looking at, okay, do we have the right kind of industry to to retain our talent, right? When you have, when we train our youngsters to become, specialists in certain area, the industry also has to, match up to that, right? Because I remember. Again, this is not the intent to criticize the government or previous government. We built a program on biotech, for many years, and we send talents overseas to learn about biotechnology. But when they came back to Malaysia, I think many of them could not land into any particular job, right? And I think that the issue that we understand from the industry is and I think there was two also misunderstanding in terms of what the job entails, because when they the students go out and learn about biotech, they expect to be more like a glamorous job, and whatnot. They don't expect what they have to do when they come back home and interview, because as a bioscience, you have to work in the lab. So so these are kind of could be something that throwing off a lot of young talent when they come back. Oh, I have to go and work in the lab. So you see a lot of biotech, graduates are not doing biotechnology these days, and also the misunderstanding in terms of the requirement from the industry. Perhaps we did not do a proper so-called requirement analysis to say what kind of skills they need, because even they have the undergraduate level biotechnology, bioscience, biochemistry knowledge, they don't have the so-called the hands-on skills to actually to be successful to work in the lab or meet the requirement of this industry. So there's a kind of a conflict of a requirement and also the expectation of both sides, right? So I think we should not make any mistake when we want to move into new industry or bring new industry or train new talent for new industry. Make sure the requirement between the talent producer and the research perhaps and the industry are matched, right? And require a bit more effort than say, let's go into biotech, let's go into this particular tech, right? So I think that's something we need to learn from. The brain drain is because of that. I think that's why when we look in terms of the industry development, it has to impact the so-called the bottom line with the FDI or DDI, right? If we don't have that, you can have as many good talent from Malaysia, and they will end up working for somebody else. But it's good to hear, a Malaysian work for Tesla, for example, a Malaysian work for a big corporation in the US. But we need to serve the bigger agenda of the country, right here, right? So therefore, there has to be an open conversation between industry and also the government and academia in terms of where they're going next. So there's no point to just bring industry to come here and hire Malaysian as their engineer, but we're also not building our own capabilities, our own IP or technology that Prof. Dr. Helena was talking about. So it has to be a win-win. You must have the foreign investment that are the market leaders in Malaysia to drive the technology and also the economy. At the same time, local has to step up and say, now can I do and support those companies, not just providing talent, but can also providing the technology for this company to eventually source their technology from me, right? And eventually maybe have your own company. So there are a bit of a complex kind of equation here. But at the end of the day, you need to understand in terms of why people leave, why you have brain drain, why you have technology drain. I guess with the IP protection and whatnot, I think Malaysia has a pretty good IP protection, and also the ethics among Malaysian, compared to some other countries that I know. So therefore, I think we should not have any kind of IP technology drain. I think in that pretty much in a good state, I suppose. Yeah.
Right. And with that, the Live Malaysia Support Committee as organizers would like to thank our 3 panelists for their valuable insight and our audience for the questions. Please fill up the exit survey in the description section so that the organizers can send an acknowledgement of attendance for you to be with us. If you don't get the acknowledgement of attendance, please check your spam folder or email us. This is the last of the Live community activity scheduled from Live Malaysia for the year 2021 under the Royal Academy of Engineering UK Live Community Grant. We would like to thank everyone for supporting the forum sessions, and we will together build the future for Malaysia through innovation. Thank you.
Thank you.
Thank you.
Thank you, everyone.
Thank you.
Bye.